Half subtractor and full subtractor. Half subtractor. The half subtractor is constructed using XOR and AND gate. The half subtractor has two inputs and two outputs. The outputs are difference and borrow. The difference can be applied using XOR gate. Borrow output can be implemented using an AND gate and an inverter. IC of AND gate is 7408 and IC of OR gate is 7486. This is the logic diagram for the half subtractor. When A and B are both 0, then the outputs borrow and difference are also 0. When A is 0 and B is 1, then the outputs borrow and difference are both 1. When A is 1 and B is 0, then the outputs borrow is 0 and difference is 1. When A and B are both 1, then the outputs borrow and difference are both 0. This is a Boolean expression for the half subtractor. And this is the circuit design. Now I'll be explaining about the working of the half subtractor. When A and B are both 0, then the outputs difference and borrow are also 0. When A is 1 and B is 0, then the output difference is 1 and borrow is 0. When A is 0 and B is 1, then the outputs difference and borrow are both 1. When A and B are 1, then the outputs difference and borrow are both 0. Full subtractor. Theory. The full subtractor is a combination of XOR and OR NOT gates. In a full subtractor, the logic circuit should have 3 inputs and 2 outputs. The two half subtractor put together gives a full subtractor. The first half subtractor will be C and AB. The output will be the difference output of full subtractor. The expression AB assembles the borrow output of the half subtractor, and the second term is the inverted difference output of the first XOR. This is the logic diagram for the full subtractor. This is the truth table for the full subtractor. When A, B and B in are all 0, then the outputs borrow and difference are both 0. When A, B are 0, B in is 1, then the outputs borrow and difference are both 1. When A and B in are both 0 and B is 1, then the outputs borrow and difference are both 1. When A is 0 and B in are both 1, then the outputs borrow is 1 and difference is 0. When A is 1 and the remaining B in are 0, then the outputs borrow is 0 and difference is 1. When A and B in are both 1 and B is 0, then the outputs borrow and difference are both 0. When A and B are both 1 and B in is 0, then the outputs borrow and difference are both 0. When all the inputs A, B and B in are 1, then the outputs borrow and difference are also 1. This is the Boolean expression for the full subtractor. And this is the circuit design. Now I'll be showing the working of the full subtractor. When A, B and C are all 0, then the outputs difference and borrow are also 0. When B is 1 and the remaining inputs A and B in are both 0, then the output difference and borrow are 1. When A and B are both 0 and B in is 1, then the outputs difference and borrow are both 1. When B and B are both 1, then the output difference is 0 and borrow is 1. When A is 1 and the remaining inputs B and B in are 0, then the output difference is 1 and borrow is 0. When A and B are both 1 and B in is 0, then the outputs difference and borrow are both 0. When B is 0 and the remaining inputs A and B in are both 1, then the outputs difference and borrow are 0. When all the inputs A, B and B in are 1, then the outputs difference and borrow are 1.